In this video, we're going to see how to interpret our row operations as matrix multiplication. So the first thing to remember is that matrix multiplication is composition of linear maps. So we really want to think about this in terms of linear transformations. So let's look at this first question first, giving a 4x4 matrix that can be used to perform the row operation. The third row goes to the third row plus 4 times the first row. So I want to think about the linear transformation that goes along with this matrix. So we don't know what it looks like yet, but we're going to take something that looks like the identity matrix and tweak it slightly to make it work. So for the moment, let's just suppose we had the identity matrix, and then we'll come back and change this once we figure out kind of how we need to change this to make it work. So I'll write down the identity matrix here. All right, so what does this do to a vector in R4? Let me just write down kind of an arbitrary vector in R4, x1, x2, x3, x4. All right, so we apply a linear transformation to a vector. Remember, we're doing linear combinations of the columns here. So this is x1 times the first column, which is 1, 0, 0, 0, plus x2 times the second column. So that's 0, 1, 0, 0, plus x3 times the third column, and plus x4 times the fourth column. All right. And if we just do this as it's written, then we end up with x1, x2, x3, x4. It's not surprising, the identity matrix left this thing alone. Okay, but that's not exactly what we're after, right? We want to send the third row to the third row plus 4 times the first row. So let's kind of work a little bit backwards here. Instead of this vector, x1, x2, x3, x4, we really want to end up with x3 plus 4 times x1. So 4 times the first row added to the third row. So if we want to get an x1 in the third spot, the only way we're going to get an x1 is to change what's going on with our first vector, because that is the only place we see an x1. We want to see it in the third row, so we're going to have to change the third row here from a 0. Let me erase that 0. And so instead of just getting x1 times 1, 0, 0, 0, we want x1 times 1, 0. We need a 4 there instead of a 0. So now we can go back and change our standard matrix to reflect this. So the only one we changed was the first column, so we'll come back and change our first column here. So now this standard matrix goes with our linear map here that took the vector x1, x2, x3, x4, and it's sent it to x1, x2, x3 plus 4x1 times x4. All right, so this does the trick for the first one. Now let's think about what if we were going to swap a couple rows. Okay. So let's let, I don't know, how about S going from R4 to R4 be the linear transformation with standard matrix Q. And we're going to tackle this in kind of exactly the same way. For the moment, we'll say Q is the identity matrix, and then we will kind of work through to the end and then work backwards. All right, so what should S of x1, x2, x3, x4 look like? Just like before, because for the moment Q is the identity matrix, we'll just have x1 times the first standard basis vector, x2 times the second standard basis vector. That should be a 1. Plus x3 times the third one, plus x4 times the last one. And once again, If we leave Q as the identity matrix, we'll get x1, x2, x3, x4. But that's not what we want to get. We want to have the second and the fourth ones swapped. So x1 and x3 should be the same, but instead of x2, we really want an x4, and we really want an x2 here. So now we have to fix our part over here to make sure that we end up with x1, x4, x3, x2 here. And now the idea is we basically swap the roles of x2 and x4, right? We really want to get x4 multiplied by 0, 1, 0, 0, and x2 multiplied by 0, 0, 0, 1, because that would put x2 in the bottom spot and x4 in this spot. Maybe I'll just come here and cross that out and put an x4, and cross that out and put an x2. Now, before we go back and fix Q, I'm going to write this again, okay, but put the variables in the correct order now. So x2 is now multiplied by 0, 0, 0, 1. And x3 is still multiplied by 0, 0, 1, 0. This spot, this x4 is multiplied by 0, 1, 0, 0. All right, so now we'll go back up to our matrix Q. x1 is still multiplied by 1, 0, 0, 0, but our second column should now be, that's not an eraser. Our second column should now be 0, 0, 1, 0. Once again, the erasing is not working. There we go. So we're going to erase this column and add in 0, 0, 0, 1. The third column, 0, 0, 1, 0, that stays the same, but our fourth column changed here. So let's erase that. And now our fourth column should be 0, 1, 0, 0 to match what's going on down here. Okay. So now this matrix Q lines up with our linear transformation with the blue corrections that swaps the second and fourth rows. All right, so that's two of our three row operations. We have one more kind of row operation. So let me clear us a little bit of space here. All right, so now let's find a linear transformation that goes with our standard matrix B, which again, just for the moment, I've put in the identity matrix as a placeholder, and we'll correct that in just a second. We want to see what happens to x1, x2, x3, x4. So for the moment, this is going to x1 times the first standard basis vector, just like before. All right, so if we compute this, we'll get x1, x2, x3, x4, because that's what the identity matrix does, or the identity linear transformation. It leaves things alone. What we really want to get instead is we want our second row to be multiplied by -5. So instead of a x2, we want a -5 x2, and then x3 and x4. All right, so instead of an x2 here, we want a -5 x2. So we're going to look over here where we produced an x2. And instead of getting x2 times 1, we want x2 times -5. So instead of the 1, we really want to have a -5. And now we do this, we'll get 0, -5 x2, 0, 0, added to the other things which remain the same. So to fix this, we need to go back to our standard matrix and make the second column look like this column now. We only changed one component there. So we'll go ahead and fix this second column. So we should have 0, -5, 0, 0. And now this matrix B will correspond to our linear transformation that sends rho 2 to -5, rho 2.